Welcome, everyone. Thanks for joining. We'll get started in just a few minutes. Welcome, everyone. Thanks for joining. We'll get started in just a few minutes. Well, welcome, everyone. Thank you so much for joining us today. We're excited to see you. We're here for the AI and root cause analysis from detection to prevention professional development session. My name is Brittany Holmes. I'm an associate director with ASU's Ira A. Fulton Schools of Engineering in the Global Outreach and Extended Education, or GOE office. GOE brings the vast expertise of ASU engineering faculty and enables online engineering degree programs, professional programs, custom programs for industry, as well as government and academia, and supports capacity building projects around the globe. Today's session is part of the ASU Engineering Professional Development Series, and our goal here is to connect all of you joining, whether students, faculty, current professionals, or alumni, with engaging professional development opportunities. Our agenda today consists of some brief polls. We'll get to know who's in the room, and an engaging presentation by our industry speaker and black belt instructor, Jim Boblett. We'll also have some time for Q&A and some wrap up. We'll cover some of our upcoming courses. We invite you to enter your questions into the Q&A throughout the session, add any of your comments into the chat feature. And while you are muted, we hope you'll engage with us through those polls and the Q&A in the chat. Before we launch into the presentation, I wanted to just take a moment and go through a few poll questions with you today. This helps us get to know who's in the room. So I'm going to ask Nick to go ahead and queue up these polls. And if you would just take a moment, answer these, it just gives us an idea of what some of your biggest challenges are with traditional root cause analysis in your organizations, and helps contextualize as Jim is presenting with us, give him an idea of some of the challenges that you are facing. So looks like we have quite a bit with a reactive approach. The problem's already occurred by the time you're doing root cause analysis. Taking some time to address what the root cause is in the organization, lack of skilled practitioners, and human bias affecting analysis quality. Wonderful. Thank you for those who have answered. We're going to, let's see, we'll give it one more second. Yeah, so it looks like pretty high on human bias and this reactive approach. So problems have already occurred. Let's end this poll, and I believe we have one more question we would like to ask. So hopefully you all can see the responses of the poll. There we go. So appreciate all of you taking the time to take this one. Let's go ahead and launch the next poll. How would you describe your organization's current use of AI in quality and operations? So whether you're not using AI at all or you're exploring and implementing, if you have some basic tools in place using for predictive analysis, or if you're advancing AI across multiple processes. I'll give you all a moment to take this one as well. Wonderful. It looks like we'll go ahead and share out these results. It looks like the majority are using some basic AI tools already, a few not using AI at all yet, or just sort of in that exploration stage. And then a pretty small number are advanced users, or just one advanced user. So thank you. Appreciate that. And I think really wonderful, helpful context for us. I would like to now go ahead and transition and introduce you to Jim Boblett. He is a Lean Six Sigma Master Black Belt with more than 20 years of experience driving operational excellence across industries worldwide. He began his career learning the Toyota production systems at Rubbermaid in the 1990s and went on to earn his Master Black Belt certification from Arizona State University. Since then, Jim has led Lean Six Sigma rollouts in the US and abroad, trained and certified over 300 professionals, and built a reputation for improving processes, solving complex problems, and empowering teams to achieve lasting results. So with that, I'm going to hand this over to our speaker, and thank you for joining us.
Thank you, Brittany. All right, welcome everyone. Thanks for being here for the AI and root cause analysis, or RCA, as we'll know from now on. We're going to be looking at this from detection to prevention. I know it's from things there's a lot of human bias, lack of skilled RCA practitioners, and the RCA or AI is reactive in nature currently across the board. So thank you for answering the polls and getting that. It gives me a little bit better context where we're coming from, and the fact that the majority have some current AI tools in place, but nothing fully rolled out yet. So we can go to the next, go over the agenda. So what we're going to do is go through a quick refresher. We're not going to dive deep into the RCA tools, but just a quick refresher of what they are, how to use them, and how that will help us with AI, right? How it's a foundation for AI. And then where data meets root cause analysis and what that means as far as providing inputs to AI, the outputs from RCA. And then some AI techniques. We're going to look at anomaly detection, predictive maintenance. And it says predictive maintenance in here, but please think of whatever your industry is. It doesn't necessarily have to be predictive maintenance, because AI tools are good for even if you have transactional processes. RCA tools apply, and AI is also, they still work well for almost any process that exists where you need something, some kind of interfacing. We're going to look at industry impact, what that means. If we do this, what can we expect to get from it? We're going to look at some actual case studies. What happens, again, what can you expect and what can your company expect if you make this investment into AI? And then the implementation, the fun part, right? The roadmap, what we look for, the metrics, the risks, and then the next steps for organizations that are just starting out. And I noticed in the poll that there were a few companies that didn't really have anything yet, or are just kind of looking into AI, and whatever that may be, whether you're looking into AI to help out with documentation, or whether you're looking at it for actual processes, manual or automated processes, this will all be applicable. Right, next. So what is data? I wanted to start out with this, and I know there's two quotes here by Lord Kelvin, but it's because I love both of these. He says, I often say that when you can measure what you're speaking about and express it in numbers, you know something about it. But when you cannot measure it, when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. What that means is if you can't, we talk about data, and data has many different forms, but what we're looking at specifically in this for root cause analysis and the AI, how it connects with AI into the predictive world, is the numbers side of things. And if you can't measure it, you don't know your process, right? You haven't delved into it enough. And if you can't characterize, you don't understand your process, then it's of a meager and unsatisfactory kind. I know meager is misspelled because it's the British. It was the quote. So I just wanted to keep that there. I know it's not the English spelling. And then the other quote, to measure is to know. If you can't measure it, you cannot improve it. And that speaks to baseline, right? When we're working with something, we need to know where we are. Before we're going to start a journey or anything else, we need to know what's our starting point. And that, if we have to be able to measure it to know where we are in order to know whether we're going to improve, we need to improve, or whether we have made any improvements yet. So again, two great quotes that I love. And then I have the Kaizen burst up there. It says, don't gather data if you're not going to use it. I know too many companies that have tons of data where it's not needed, and no data where it's really critical, right? We really need it to improve processes. And anything that we're doing like that is a waste of energy, time, space, people's resources, things like that. We just want to make sure that we're not gathering data just to gather it. And one last statement: if you have equipment that currently does not have data coming from it, there's typically ways to gather that data. I know in the past, we've had equipment that we're looking at that was a piece of automation that was being reported at 67% OEE, which is overall equipment efficiency. And that's a compound formula that comes up with it. But basically, how well is the equipment running? And they were having a hard time getting product out, but it was saying they were 67%, so they expected a lot more product than what they were getting. There wasn't any data able to be taken from it. But what we found, we went in there, is myself and a counterpart, is that there was a PLC, right? Where people were trying their best to log things by writing it down, right? They had a whole log sheet and all these different things, but there were so many micro stops that by the time they would start to write something down, they would notice it had paused, start to write it down, it would start up again. They didn't have time to do it. So it was a pretty fast-paced machine when it was going, and with a small buffer to use. So anyway, a lot of it went unnoticed. We were able to tie into the PLC, got the signals from that, created a program in laptop, and had a friend of mine create a board to take those signals and actually into something that I could use in the program that I made to counter all the downtime, different stop and start timers in order to gather data. Again, that's an extreme measure, but it was something that was extremely important, and we had to make it happen. So there are opportunities across the board for data, even if it's just sitting down and stopwatch and writing things down. So again, lots of opportunities to gather data, but we need it before we start. Thanks. Next. There we go. Thank you. And why does RCA still matter? It's a cornerstone. RCA is a cornerstone of making any improvements prior to going into anything predictive. It provides the causal clarity by uncovering things that you normally wouldn't know, using the methodologies, it's some of the lean tools, the RCA tools, the 5 whys, fishbone, fault trees, FMEA, or failure modes and effects analysis. And we'll talk about that a little bit more, as well as a SIPOC and a process map. But those provide some clarity that go into the inputs to help guide the models that we're creating to predict things in AI. And then likewise, that helps to avoid waste, right? If we're using this, we're able to get myopic on the things that matter most, data-driven focus, in order to understand what's really important for AI. What are we looking at? What helps us, the biggest bang for the buck, so to speak. And one more Kaizen burst up there: never automate anything until you understand the process. Again, I've seen this so many times in industry where something's wrong and people will just, hey, we need more information, or people are messing up, which is never good to blame people to begin with, right? We blame a process and not people. So you need to understand the process and what is allowing the faults or whatever to happen in the process before we try to automate anything. Because again, I've seen it many times, whether it was transactional processes or actual manual processes, where they've taken and said, oh, we're just going to automate this. We're going to build some automation and we're going to save time. And actually 3 times, when they didn't go back and make a good process ahead of time, understand it, characterize it, reduce what they could manually before automating, extreme inefficiencies. Actually, 2 of the automated systems were shut down. The other one, they ended up having 1 extra person added to it. So instead of having 5 operators, they had 6 operators in order to keep it running, plus a full-time technician to staff the piece of automation, after spending over $3 million on this piece of automation, all because they didn't use RCA tools, understand, characterize, and make the best possible product prior to automating. And with software, it's the same way. You get 1 chance with software. You roll something out, if it doesn't work the first time and you didn't deliver a good product, people are going to be done. They're not going to have any trust in what you're delivering anymore. So again, a few things on the foundational side, understand prior to doing any AI or any kind of automation. Next. And then some of the typical AI tools and the AI ready output. So whatever we get from 5 whys and fishbones, when we do those, we should have 3 to 5 things within a fishbone that we are looking at that are potential root causes, right? So then we would take those and we would use that to plan out AI. Do we need something in this? And then whether we're looking at temperature or vibration, standard process step that we may not have sensors on or anything yet, but it'll help guide us to where we should be looking, right? And not look at the process as a whole. Again, helps us get a little more myopic and zoom in on where we should be. SIPOC, that's a supplier's input, process, output, and customers. The customers aren't part of this when you're looking at it for AI necessarily, unless it's an internal customer and what input we're providing to the internal customer. And then process mapping, extremely important to understand the process itself before using failure modes and effects analysis or the FMEA. And when I talk about, I just want to clarify something. When I talk about process map for RCA, I'm not talking about a process flow chart, anything that has decision diamonds or anything like that in it. We're talking about a process map that where you walk the process, not rely on work instructions or SOPs or anything like that, where you actually walk the process and look at every process step and clarify every input that goes into that particular process step, and then the output that comes out of that at each specific step of that process. Because if you don't have that and you create an FMEA, you're only going to be guessing, right? You want something robust. You want to walk the process and do your process map, and then use that process map they plug directly your process step, inputs and outputs plug directly into your FMEA, and it'll be extremely robust and something that you can truly use for your AI, right? You're ready at that point to use for anomaly models and things like that. Whatever you need, you'll have the correct inputs that are needed for it. Next. So how AI extends RCA, again, from detection to prevention. So it helps classify anomalies, different types of failure modes, like we just talked about within the FMEA, using unsupervised learning methods. That's in the beginning, right? Later on, we can use supervised learning methods. Diagnoses, right? So we want to map anomalies back to the RCA, and they should be part of our FMEA. If we've done due diligence in our process map and our FMEA, mapping back anomalies shouldn't happen, or they should be extremely rare, because we've characterized the process, we know it, we understand it, and we've already accounted for potential anomalies in the system. So that's the diagnosis side. And then into the prevention, right? We want to predict failures ahead of time with predictive maintenance. Again, we talk about predictive maintenance in here quite a bit, but this is also pertinent to any other process that, whether again, transactional, human, or current automated, machine automated process. And the reason I have fraud prevention up here is I just want you to think, again, understand when you're looking at RCA and AI, I want you to have that personal connection with it. So think if you were a victim of some type of fraud, right? Identity theft, somebody charged up a bunch of money on your credit cards, or heaven forbid your debit card, right? Drained your bank account, or maybe they stole your title to your home, right? Now they own it and you get kicked out, right? Would you rather have detection on that and find out afterwards? Or would you rather have it prevented to begin with? I know it's kind of a stupid question, but it's just saying, put yourself in that mindset. Think the same way at work, right? We would rather prevent things. It's always better to prevent than it is to find out afterwards. And again, that personal connection, understanding how would I feel? I should feel that same way at work if something happens, right? If we're having to go back and waste time and effort and stuff like that, we've already messed up something down the road. Whether it went to the customer or whatever, we want to make sure we prevent that from happening. Okay, next. This is kind of neat, actually. When I started diving into this, it's been a little while since I've looked into the market itself, but the growth is phenomenal, actually. The rapid market growth, and this Markets and Markets projects that predictive maintenance in US dollars was 10.6 billion in 2024. And will be up to 47.8 billion by 2029. So that's roughly 35% annual gain in revenue year over year, right? So there's going to be a lot of money expected to be put into AI and predictive maintenance over the next 4 years. So companies or customers are going to be looking for companies that have that. And what some of the things that we can control as a company are how much it costs us, how well we do with reducing defects, reducing downtime, things like that. That the less it costs us to get product out to the market, the better off we're going to be, right? The more we're going to be competitive in the market. And so some of the other research firms, IMARC, Grandview, and Technavio, forecast some of the same type of things, right? Across the board. Again, not just predictive maintenance, but a lot of the AI overall across many industries. And then we just want to make sure that the company's positioned, right, to be a mainstream, to have that AI investment, to be able to attract more investment globally. And there's going to be a lot put in there, a lot of money put in there. And we'll talk a little bit more about how to work that and how that works within the company to get buy-in for it. But you'll notice at the bottom I have PDM. PDM means predictive maintenance, and as we go into the next, you'll see a few key indicators, just so I don't have to spend a lot of time explaining what they are. But PDM will have the next one, that's predictive maintenance. So we can go on to the next. Thank you. Some of the aerospace industry has been one of the top in monitoring and using AI, Rolls-Royce being one of them. And they use just multiple, at least a dozen sensors, or dozens, sorry, of sensors to monitor everything within their motors. So they use it on their line when they're building them, but they also build monitoring into the engines and stuff like that. And what that creates is an automated pipeline between the engine itself, the pilots, and any ground crew, anybody that's looking at or receiving that information on the ground. And as it's broadcast, it makes that data available so that they can understand when this plane comes in, we're having a problem with this. We need to get it. They can look at with the detection of the anomalies, they can have parts ready, they can have people ready, and have it ready to go in so that they can improve their uptime and their readiness. Because again, what's the one thing that's important to airlines? Well, what's important to us, right? On-time departure is important to us, but it's also important to airlines. That's the number one metric and what they get measured on. And if you come in and then you find out there's something wrong, or they have to tell you after you land, you don't have the parts ready, things like that, it can stall. And not everybody has extra planes that they can just pull up and roll out. So again, extremely important in streamlining the amount of time that it takes to get that information and to be able to rectify whatever the problem is. I love the CEO. I was watching a podcast the other day, or a webinar, sorry, and the CEO of Delta, Ed Bastian, was on, and he was talking about, he considers AI, not artificial intelligence, but augmented intelligence, because they use it, they still need the intelligence of people, and it's not artificial because people have the input into it currently, and they're using it again for the consumer as well as for their predictive maintenance and stuff like that, right? And helping out what's important to us as a customer. And they're using that in the apps and all kinds of stuff to make flying better. I know all the airlines are starting to do that, but it was just interesting to hear his take on that. Okay, next. So the industrial manufacturing, Siemens and GE. So Siemens has software that will basically monitor a whole plant, where they come in and you see the robots on here, they'll actually come in and grab the data from all of these different pieces of equipment and turn it into IoT. I don't know if anybody's heard of IoT, or the Internet of Things. It's been around for, I don't know, well over a decade now. But basically just means many things, one view, right? So it's monitoring many things just with a singular view of what's pertinent to that particular person. And it's different for every step of the facility. And so they're looking at, again, taking all that data across entire plants and look for maintenance recommendations, anything they can do that would help to predict if they have some sensors, right? You see the welding robots and they have, sensors on them and stuff like that. Maybe they're fiber optic sensors, and those arms, 6-axis robots, they articulate quite a bit. Maybe the fiber optics are breaking after, 10,000 hours or something, they will know that, and they'd be like, okay, we're going to replace these every 8,000 hours, right? So we get to predictive. So basically, we're able to control the time that the equipment is down, and not the equipment control the time that it's down. That's we're looking at those opportunities when we have time, when we make time for it to happen, to keep everything running. So again, it goes throughout the system, and they create the predictive maintenance workflows by gathering all that data. And GE does the same type of thing, right? They use it for early fault detection, maintenance prioritization. GE does so many different things. They make PLCs, they make motors, they make tons of stuff, as does Siemens, a lot of things. But the point is, this is pertinent in these industries as it is in the aerospace industry, as it is in every industry, right? For whatever we need, we can use that data to gather and make data-driven decisions on what to do and keep things running, and to alert us when something potentially could go wrong. We'll see that in the next example. Number 3, being cross-industry and academic evidence. So looking at systematic reviews and model accuracy. I thought this was pretty neat, that the strong model accuracy, some of the academic reviews, the Random Forest actually has a predictive model. They make the software and stuff like that. So they're doing roughly 80% accuracy on predictive maintenance tasks, which is pretty phenomenal. I don't know, some people may think, oh, it should be, 99%. 80% or roughly 80% is really good, because there's still people have to do the input. And if you're not doing the RCA in the beginning, I can tell you that 80% should be much higher if we're doing things the right way, right? If we do RCA first before creating AI. That's what that does, is it provides a reduced financial impact, right? So you have your upfront costs, but you can offset that by predictive modeling and being able to get ahead of things. Again, reduce the cost burden of unplanned downtime. And looking at the consistent benefits, but again, dependent on how good the inputs were to the AI to begin with. So again, relying back on RCA, and if we don't do it, then it's of meager and unsatisfactory understanding, as Lord Kelvin would say. Okay, next. So RCA to predictive pipelines. And the architecture we're looking at here starts out with the data layer, right? Sensors, MES, and SCADA systems, logs, maintenance, again, anything that's handwritten, stuff like that you can get into the system, whether it goes into an actual data lake or whether it's processed, ETL done right away and then analyzed, whichever whatever the ETL means, to extract, transform, and load. I want to make sure that that's one I don't have on there. So it's just a method of taking the data, transforming it into something that's palatable, and then loading it into the system. And then modeling, again, anomaly detection, unsupervised, supervised prediction, and then prescriptive for different types of interventions. So supervised would be like what we talked about with the fraud, right? The fraud, cybersecurity, different types of manufacturing. That would be supervised, because it's making a decision. If we wait, if there's a delay in that decision for cybersecurity or in fraud cases, bad things can happen, right? A lot can happen in a matter of milliseconds. But the supervised thing helps, and then warns somebody, right? So it's done what it's supposed to do, and then alerts, right? So it's not alert and then wait and let you intervene, which is an unsupervised. And then there's boards, alerts, different work orders, things like that happen in the operations. Some people have tier meetings and things like that to help out with some of that information. But the feedback loop is where that typically happens, because it's reactive, right? So something's happened, we use that feedback loop to then feedback into the AI. And next. So now the fun part, the implementation roadmap. So this is a standard kind of rollout, 6 to 9 month plan. Phase 0, I would actually venture to say there should be a ground zero. Well, that sounds bad. I don't mean ground zero, but stage before phase zero, T-0. And based on what was in the poll earlier, the lack of skilled RCA personnel, understanding that needs to be a foundational part of what happens prior to even beginning to roll it out. You need to have people that are very good at what they do, that are experts in that field and can help out and train others. And they should be the ones that are getting the data and providing everything for this phase zero. So you're going to conduct the workshops, map the key processes as we talked about, select pilot assets. So we want something, a line or two lines, one or two lines that are high failure costs, right? So we can justify what we're doing, right? Because a lot of times to implement something takes a lot of money, right? It's kind of getting that water wheel moving in the beginning. It takes a lot to get it started. But then once you're going, you're able to see the benefits. So the high failure cost and good instrumentation, the reason we want good instrumentation and not a piece of equipment like I mentioned earlier, is that we want to be able to jump in and understand that process as easy as possible. We want to make the first pilot as easy as possible, right? So we're going to go after the high value, best instrumented lines where possible. You may not be able to do that. That just takes a little more time. And then phase one is where you're setting up the data collection, installing the sensors, right? If you've done the RCA workshops, you know where the sensors should go. You're integrating everything into that data lake or into whatever you're using to gather all that data, using the RCA outputs that will then go into phase two, which is where you develop your anomaly detectors, supervise predictive maintenance, and deploy alerts for any kind of early evaluation. And then you're going to expand the scope, right? Once you're at that point, you're doing well, you're going to do prescriptive recommendations. You're going to integrate it with other things. You're going to have measured ROI. That's critical for buy-in and for moving to the next level. You have to have ROI in there to show, here's what we've done, here's what we've spent, here's where we are, and here's where we expect to be in whatever duration of time you're looking at. But you need to have the ROI to help for buy-in from leadership and to continue that process. So, all right, next. Some of the key metrics to track, right? While we're doing this, we want to look at the technical metrics, anything that the false alerts, the time to detection, the AI model effectiveness, right? We want to have an efficacy test to understand how well it's working, right? If we're wasting a bunch of time on false alerts and things like that, and we're not feeding stuff back into that AI model, we need to maybe pause and go back and do RCA and understand what's going on, or a deeper dive into the current data that we were able to gather. And then the operational metrics. So unplanned downtime, mean time between failures, scrap rates, anything like that, maintenance cost per asset. There's MTBF, MTTR, mean time to failure, mean time to repair, sorry. All of those things you want linked to the plant performance, because you're going to get more buy-in that way as well. If things are linked to the plant performance KPIs, you have a lot more buy-in from everyone around. And I would also recommend getting people involved that aren't just engineers or just technicians. Get people involved that are going to be part of the process so that they are part of championing that process and part of the solution, as opposed to having something just dumped on them. Oh, here's a solution, deal with it, without being a part of it. Buy-in is a lot easier if you get people involved. You have early adopters in these types of things. And then the business metrics, obviously linked to plant performance, but also corporate KPIs, things like that where possible. How are we doing with our customers, right? What's our service level agreement adherence and safety incidents? Those are always extremely, extremely important. Next. And then risk and mitigation. So making sure it's trustworthy, sorry. And without disciplined RCA and governance, which we talked about, disciplined RCA beforehand, and the governance, they risk poor data. And if there's poor data, they're likely to fail. right? Again, you get one chance to roll things out. You want to make sure it's as robust as possible. And then explainability and trust, right? Again, like I talked about before, getting people into the team as early as possible, because the operators, people that are using this or having it pushed on them, need to understand what's going on and why are we getting all these flags? Why are we flagging these issues? What's the reason for it? And if they're in it, even if it's just before the rollout, to help them understand what's going on, it's better than nothing. So we want that high level of confidence with the people that are involved in it. And then alert fatigue. If we do too many false alarms, things like that, then maintenance is gonna, or the technicians or engineers, if they're constantly being called to work on or check on these things, whatever it is, then they're gonna overwhelm. And if we have things going over and over again, we become desensitized to it. We have alarms go off, alerts go off, and if we know they're either false or low priority, they're not gonna pay attention to it anymore. So that creates another risk with human intervention on that side of things. And then telemetry models, making sure they're secured to prevent misuse or tampering. And depending on what kind of industry you're in, if it's a highly regulated industry, they may require, security pass levels, things like that. Don't ever have just one person that holds all the keys to something. But again, depending on the regulatory body or the governing body, they may require that there are different password levels for things, and then ensuring that your equipment, while you can get the data off it, some may not be able to DoD things. You can't have it connected even to the intranet. You need to go in and actually pull the data off with USB, and there has to be chain of custody and all kinds of stuff. Again, depending on your business and what you're working on. So again, just ensure that it's secure and it's private. Before moving on, and then next. So we're gonna finish with the call to action. Again, next steps, because we want to move from detection to prevention. And the steps to do that, you run your RCA workshops, make sure you have people that are good at doing RCA and running and understanding it. Again, one or two high value assets, strong instrumentation and downtime cost, then define the success metrics. You want to set those targets, whether you're improving, right, your uptime or reducing downtime, whatever that may be. Cost avoidance, hard cost savings, safety KPIs, things like that, and ensure that they're linked to site and corporate KPIs as well where possible. Then you want to launch your pilot, again, using RCA guided labeling. And I'm going to say it again, before you do all that, walk the process, whatever that may be, walk the process, write down step by step what that process is. And a process step is a verb, right? It's an action. It's something that transforms your inputs into an output. So whenever you're doing your process maps, make sure that you walk the process and get that information ahead of time, so you're good to go when you kick this off. And then scaling up, right? So you want to use what you learned from there to expand predictive maintenance or whatever you're working on, whatever AI you're working on, creating those prescriptive interventions and predictive modeling for whatever is going on in your enterprise. And with that, I'll turn it back over to Brittany. Thank you.
Well, thank you very much. We did have an additional poll we were going to get pulled up here. If you could implement one AI enhanced RCA capability tomorrow, which would have the biggest impact? So automated pattern detection and historical data, real-time anomaly detection and alerts, predictive failure analysis, bias reduction, automated report generation, and Jim, if you have thoughts as we will pull up and share these poll results and quizzes, feel free to jump in here.
All right.
We've got 7 people responded so far, but we'll give this another minute and get a few more responses coming in. Early early results showing that automated report generation and recommendations are trending highest, along with predictive failure analysis. Here we go. We'll give it just one more minute here. Responses are starting to even out a little bit. Awesome. We'll go ahead and close out this poll and share these results with everyone. Looks like automated pattern detection and historical data and automated report generation and recommendations. Wonderful. Jim, anything you want to add on these?
I was to say the automated report generation recommendations, that's kind of, that's a good one. That's a good one. I figured the predictive failure analysis would have been a little bit higher, but that's it's good to see where people are currently, the detection, pattern detection, report generation, recommendations, historical data. Some of these kind of go together, but it's good to see where people are and what would have the biggest impact on where they are currently. Right? So every company's at a different place.
Great. And I know at this time we also want to invite any questions that you might have into our Q&A. Looks like one is around getting the copy of the slides. So we'll connect, and Jim, if these are slides that you're willing to share, then we'll get those shared out with the group afterwards. Any other questions related to some of the content that we have here? Anything that Jim had gone over in the presentation that you have clarifying questions on, or want to jump in and make any comments about in the chat, feel free.
I know I've said it before, I just have to say it again. Walk the process, please, 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 before you do anything. It doesn't matter whether it's RC or not. Walk the process, understand what's going on with that particular process before making any decisions, right? Always use data to drive what you do. Don't rely on guesses, don't rely on people getting together and having their thoughts on it and agreement. Use the data where possible. Agreement's good, don't get me wrong, but we want to make data-driven decisions, right? We want to have that to drive what we do in order to drive root cause.
Great. Well, I'm not seeing any more questions coming in through the chat, but feel free, if you do have more come up, feel free to add those in now. While we wait and see if there's additional questions, I did want to share a little bit about an upcoming course we have coming up on root cause analysis that Jim is actually our instructor for. So feel free if you want to add anything to what I have here, but Introduction to Root Cause Analysis. This is a 10-hour course we have coming up, just going through some of the fundamentals, how to distinguish symptoms of true causes. So this is a live course. It's online, Mondays and Wednesday mornings, starting October 27th. And then that sort of flows into data fundamentals as another course under this professional certificate. Individuals will earn a micro-credential for completing this course that can be shared online on LinkedIn. But this kind of covers some of the key skills, and if it's something you're interested in, or have a team that has interest in learning more about root cause analysis to address some of the challenges that you might be facing, this is a great way to do so. Jim, anything you want to add about this upcoming course?
You've done a good job prefacing it. Not a whole lot. I know it doesn't matter where you are in your RCA journey or what you've learned. You'll definitely learn something if you go through this course. Guarantee you'll learn something new, something to take away with each one of the different courses. And they're fun.
Awesome. So yeah, the first two are offered this later this fall, and then the second two we will offer in the spring. But really excited about getting this course launched. This will be great to have some additional root cause analysis tools in your toolbox. So please consider it, and we'll definitely share this info and the flyer out with our follow-up. And then I'm not seeing any additional questions coming in. So lastly, before we pop off, please feel free if these AI related topics are of interest to you. We are kind of broad in what we're able to feature within this series. So October 15th, our next webinar, we're going to cover AI-driven battery management systems. So one of our faculty will be presenting about this, who's done some amazing research and delivered programs within battery systems. So feel free to join or share with colleagues. This is also our QR code for our LinkedIn. If you want to stay updated with the webinars and additional programs that we'll have coming up, feel free to click that QR, and then we'll also send out this information in our follow-up email. But with that, thank you so much for joining. Please join me in thanking Jim for taking the time to go through this wonderful presentation about root cause analysis and AI.